When the denominators are different, you have to make them the same before you can do any addition or subtraction. So we would want to find the least common denominator, the smallest denominator that we can turn both of them into in order to do this. Otherwise, the numerators end up becoming very complicated. So anyhow, looking at the two denominators that are here, I notice just looking at the constants, the coefficients there, I've got a 5 and a 3, and 5 and 3 have nothing in common, no factors in common. So the smallest common denominator for just 5 and 3 would be the product of the two of them, 5 times 3, which is 15. So I'm going to go ahead and write that down. Now I do notice that both of them have an x in them. One has an x and one has an x squared. So the smallest thing that I could turn both of those into would be x squared. As that first one, if I multiply it by x, it would become x squared. The second one is already x squared. So I can't reduce the denominators at all. All I can do is just multiply things in there. So anything that I do to a denominator to change it, I have to do the same thing to the numerator of that fraction. So I'm going to make these fraction bars a little bit longer. I'm going to write down the original numerator that's there in parentheses on both of them. And then we're going to figure out what we multiplied by the original denominator to create the new one there. So to get a 15x squared from a 5x, we would have had to multiply by 3 and x. So I have to do the same to the numerator on that one. I have to multiply it by 3x. For the second one, to turn that 3x squared into that 15x squared, least common denominator, I'd had to multiply by 5. So I have to do the same thing to its numerator. All right, so now that the denominators are the same, actually I think I'm going to do this in a couple of steps there. So I'm going to go ahead and simplify the two numerators that are there, and then I'll put it together as a single fraction. So for this first one, that 3x has to get distributed to each of the two terms that are there. So that would make 3x squared plus 24x. And for the second one, I've got 4x times 5, which would be 20x. And now I could put everything together there. So keeping the denominator the same, I'm just going to do what it says with the numerators. So 3x squared plus 24x plus 20x. And then combine like terms. So that would be 3x squared. 24x plus 20 would be 44x over 15x squared. Okay, and then as I mentioned on the first example, if we can reduce that, we really should. I notice in my numerator, the two terms that are there have an x in common. So that means it can be factored. So I'm going to go ahead and factor it. I'm going to take out that common factor x. That would make a 3x plus 44 inside the parentheses. On the bottom, I still have 15x squared. And then I could reduce because there's an x in both the numerator and the denominator. There's 1 in the top and 2 in the bottom. So I'm going to cross out the 1 from the top with one of the 2 from the bottom. So essentially that turns it in from an x squared into just an x. So simplified, this would be 3x plus 44 divided by 15x. And this would be the sum of those two rational expressions. Now you're going to try this example and answer on the Google form.